Hey guys, I have your notes pulled up for 11-1 day 1. This is kind of just a brief introduction to parametric equations. I don't know, maybe in physics, but I don't know in math if you've ever dealt with parametric equations, and I think they're pretty cool. So here's what you've got, and I've kind of gone ahead and filled out some of the notes ahead of time, so this can go more quickly, but feel free to always pause and copy and try to process and understand, so you can kind of go at your own pace here, sort of. All right, so I've got parametric equations. What it means is x and y are both each their own function in terms of t. So I could have written x parentheses t. So x of t is this. My x values are obtained by plugging t values into this equation. My y values are obtained by plugging t values into this equation. So here's what's kind of cool. X is changing based on t. Y is changing based on t. Let's figure out a few x and y values as t changes. So I made an x column and a y column. So I just chose, I'm going to plug in 0, 1, 2, 3, and 4 for t. So when I plug in 0 into the x function, that's what I get. When I plug 0 into the y function, that's what I get. Sub in 1, sub in 2, sub in 3, and sub in 4. All right, so what I get if I graph these as ordered pairs, I've got the point 0, 0, 1, 1, radical 2, 2, radical 3, 3, 2, 4. And you can see that this kind of looks like half of a parabola. Now, just for fun, let's look at a Cartesian equation. So let's eliminate t. Let's just look at how x and y are related. All right, so according to my original function up there, x was radical t. So if I square both sides, I get t equals x squared. Sub that into my y function. Right? Whoa. So t is equal to x squared. This is t in terms of x. Here's my original y function. Replace this with what we just said it is. Oh my goodness, it's a parabola. X and y, the relationship between x and y is a parabola. Turns out it's only half of a parabola. Why? How come? Because this only wants the positive root of t. If this had been x equals positive negative root of t, then I would have had a full parabola. But this is only half of a parabola. Okay? And what parametric equations give you? They give you kind of two things. One is they give you a shape on a graph. They also give you a hidden progression. So and t usually represents time. So if we're counting at time 0, at 1 second, 2 seconds, 3 seconds, 4 seconds, my points are here, 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 and here, then what you don't see just by plotting the points is we started here, then to here, then to here, then to here, then to here. So progression means this is where I started, and it went this way. So you get two things when you graph a parametric equation. You get a shape on a graph. sometimes kind of a common shape on a graph. But you also get progression. You can see where it started, like its initial position, and you can see what direction it went in. So we're often going to have a general shape on a graph with an arrow telling us which way it progresses. Okay, I think I've mentioned all that. Here's another one. If you look at these two parametric equations, both of them are in terms of t. And they don't look special. They don't look like anything that you would just automatically recognize. Like up here, you know, this equation is very recognizable. Those weren't. Like, I don't think you could look at those and say, oh, I know that's going to be half of a parabola. So sometimes you have to get its Cartesian equation before you can realize what the shape actually is. Okay, so we got two kind of random-ish parametric equations. Let's look at time going from 0 to 2 pi. So a couple things to point out here. Its initial position is when t equals 0. If I plug 0 into here, I get 2. If I plug 0 into here, I get 0. So this ordered pair, x comma y, 2 comma 0, this is its initial position. Two comma 0. This graph started here. Terminal position. Where did it end? So I look at what's the last time that I can use, so I plug in 2 pi. When I plug in 2 pi into here, this is what I get. When I plug 2 pi into here, this is what I get. So, turns out, starts here, ends here. Okay, so let's take a look at what the Cartesian equation looks like. Let's see how they're related. So I copied down my pink equation, and turns out that cosine is x over 2. Okay. Sine is y over 2. I'm kind of trying to solve for t, and it's not working out so well, but look, I got it in terms of sine of t and cosine of t. How are sine and cosine related? Well, a relationship that we're going to often use in parametric equations is this trig identity. Sine squared plus cosine squared equals 1. Quick rewrite. Some of you don't do well when your exponent is here. So I just put the whole sine of t in parentheses squared. Same thing, just looks different. Now, sine of t. Go back to my pink and blue equations. We have a value for sine of t. Not a value. We have an expression for sine of t. We have an expression for cosine of t. Sub them in. I subbed this one in for sine, subbed this one in for cosine, squared them. Multiplied by 4. Oh my gosh, it's an equation of a circle. It's an equation of a circle with the radius, with the center at 0, 0, and my radius is 2. So, it's a circle. Its initial position was here. Its terminal position was here. And remember I said parametric equations, you kind of get two things on a graph. You get a shape of a graph, and you get a progression. I don't really know the progression yet, because I know it started here and ended here. Did it go this way? Or did it go this way? And here's how you can find out. Sub in hang on. If it went this way, Are you with me thinking that if it goes, here's a point, here's a point, here's a point, it's going to have a positive x and a positive y? But if it went this way, its x would be positive and its y would be negative. So let's find out what my y values are like when when t is like, when t is just getting started. When t is just getting started, is my y value going to put us up here, or is my y value going to put us down here? So, when t is just getting started, let's look at what kind of y value I'm going to get. Let's plug in a small t value. How about pi over 6? Just getting started, plug in pi over 6. So sine of pi over 6 is positive 1/2 times 2, which is going to result in a positive number, not a negative number. Started here. This is the direction. It gave me a positive y value, and it's going to end here. All right, we're doing another one, kind of similar. You've got some kind of random x functions, kind of random y function. They're both trig. I'm going to approach this one the same way. We're looking at only from 0 to 2 pi. And the problem asks us to do several things, so I've kind of labeled them so you'll know where we are. Find a Cartesian equation. What portion is the graph is traced, and then where did it start, where did it end, show us a progression. Part C. So for part A, working on my Cartesian equation. Solve for cosine, solve for sine. Again, I'm going to use my trig identity here. Sub them in. Square them. There you go. If you don't recognize this, since they're different, it's similar to a circle but more stretchy. Similar to a circle but more stretchy in the y direction. Similar to a circle but more stretchy in the y direction. So it's an ellipse. I want to show you in a minute how to do this on your calculator, but let's go on to part C. I can do initial position, so plug in 0 for t. My initial position was 3, 0. Terminal position is 3, 0, so it's going to start here and it's going to end here. And again, to figure out which direction it's going in, if it goes this way, it's going to give you a positive y. If it goes this way, it's going to give you a negative y. So I would sub in a low value for t, and that's going to give us a positive result. So that's the direction it goes. Okay, and again, I want to show you this on a calculator, but I'll have to do that later when I can pull up a calculator. Okay, last one. No trig this time. Here's my x function in terms of t, y function in terms of t. Let's start at 0 and only go to 1. So you can see my initial position, sub in 0. So we started at the point 0, 2. Terminal position, sub in 1. Terminal position was 3, 0. And it's pretty easy to tell if you start here and you end here, the direction had to be this way. Kind of common sense tells us that. And then for our Cartesian equation, again, I'm trying to eliminate t. How are x and y related? So in order to eliminate t, I solved for t and then subbed in t. Turns out x and y are related linearly. Well, I think you already knew that. But again, I'm only seeing on the graph, I'm only seeing a portion of this line because I'm limited in time, basically. Alrighty. I hope you like them. I think they're kind of fun. Good luck.